Everyone, today we are going to be looking at our last piece of work for week 2. I'm going to be dealing with a topic from chapter 4. Actually, it's 2 topics. We're going to look at how to solve a system of equations. And instead of using the addition method, which is what we looked at last time, we're going to use a method called the substitution method. And secondly, we're going to look at applications. So we're going to look at word puzzles that end up being systems of equations, and we get to solve those. There's a large title. Right, let's work first on solving system of equations using what's called the substitution method. Well, we're going to have 2 equations in x and y. The main difference is that they will typically be written in the y equals format. So suppose one of them was y equals 2x add 7, and the other one was 4x add 13. I'll call this equation 1, and I'll call this equation 2. Now, in these questions, what you'll notice that both of these are in the form y equals. And so we make a pretty simple deduction. If y is equal to this and y is equal to that, then this must be equal to that. So if I set them down, the 2x plus 7, which is this guy, is equal to y. And since y is also equal to this, we get that. And you can think of it in a variety of ways. One way, hence the name substitution, is that we substitute that y for 2x plus 7. Now, what you've managed to do by this process is eliminate one of the variables. So all we're left with is an x. Now, if I subtract 2x from both sides, and then I subtract 13 from both sides, and then lastly, I divide both sides by 2, we are halfway done again. And now that I know that x is equal to -3, I shall put x equals -3 into either equation 1 or 2. Let's put it into equation 1. Y is 2x add 7. So y will be 2 -3's add 7. So y will be -6 add 7. So y will be 1. And that's us solved the problem. We have our solution. Will be x is -3, y is 1. We're finished. So that's pretty nice, pretty clean. So let's look at some other situations where that could happen. Well, suppose they gave you the equation as they did in which question? In question 11. Suppose they gave you the system of equations as x is equal to 4y plus 2, and the x is equal to -4y take away 6. There's my 2 equations. Well, it might look different from this, but it's really the same situation. If x is equal to that and x is equal to that, then 4y plus 2, which is this guy, should equal that guy. And if I add 4y to both sides, if I then take 2 away from both sides, and then I divide both sides by 8, we have half the answer. I will then put, another word for put y equals -1 is substitute y equals -1. And I will put it into any equation I like. Let's do it into the second one. So the x will be -4 times -1, take away 6. X is 4, take away 6. X is -2. And here we have the one unique solution to that system of equations. So our solution, x and y, is -2 for x and -1 for y. Now we know from other situations that if you think of these as straight lines, you might get two parallel lines, or you might get a situation where one line is identical to the other. So let's try and see a parallel line situation. Suppose I get y equals 2x plus 7. That's my first equation. My second system is y equals 2x plus 5. Now, if I take this guy, he must equal that guy. And of course, we now would try and solve for x. So if I subtract 2x from both sides, the x's totally disappear, and I am left with 7 equals 5, which we know is impossible. And what impossible means is that we are looking at that situation. So your solution, when that happens, to say inconclusive. Now, what might happen instead of that is you might get two parallel lines, but that's going to be a little bit trickier. So we'll do, not two parallels, we'll do identical lines, but let's do this kind of problem. And the one I'm going to choose is like question 12. So I have 12x take away 9y equals 1, call it equation 1. And I have 4x take away 3y is going to equal 2. It's my second equation. Now, to try and solve this using this technique here, the big problem is that these equations are written in what's called standard form, right? The x's and y's together, and I need them to be written as y equals. So I'm going to have to take each equation and do a fair amount of algebra on it. There's the first equation, to get it to be y equals. So I'm going to subtract 12x from both sides. I'm then going to divide both sides by -9. Well, -12 divided by -9 is positive 12/9, which gets you 4/3 x. And that guy gets you -1/9. So there is my equation 1 rewritten in the form y equals. And I'm taking equation 2 now, and I'm rewriting it eventually in y equals format. So I'm going to subtract 4x from both sides. I'm then going to divide everybody by -3, and that's going to be positive 4/3 x, negative 2/3, and that's going to be my second equation. Let's check a little thing here, make sure I haven't done anything wrong. This is question 12. Oh, I haven't. Now, when you look at these two equations, if I then make this equal to that, what we have is 4/3 x take away 1/9 is equal to 4/3 x take away 2/3. Subtracting 4/3 x from both sides, we get that, and we know that's impossible, that they're different from each other, and so we do inconsistent. And I call that inconclusive, but it looks like a WebAssign the preferred one, inconsistent. Okay, so let's look at if I can find one. Well, I'll make one. Suppose you get an equation like 2x plus 4y equals 10. So that's equation 1. And you get 6x plus 12y equals 30. And that's my second equation. I'm going to try and solve it by first rewriting them in the y equals format. So I'm going to subtract 2x from both sides. I'm going to divide everybody by 4, so that ends up being -1/2, and that ends up being 5/2. And that's my new equation 1. I'll now take my second equation. And I will subtract 6x from both sides. And then I will divide both sides by 12, and that becomes -1/2x. And this guy becomes 30 over 12, which ends up being 5/2. Now, when you look at these two equations, do you see that they're identical? So that would be two lines, one on top of the other. When you have that, I don't need to do any math. I know what the solution is going to be. It's going to be written like this: x, comma, that guy. Because there's going to be an infinite number of solutions. And essentially, whatever y is equal to, and you know it's the same thing in both cases here, that goes here. And that is essentially the method called substitution. And we can use it to solve a system of equations. What we're now going to look at are applications. Word stories, essentially. And we'll start off with our first example, which is going to be question 1. And question 1 has a jet plane flying with the wind. So imagine this is my aircraft, my jet plane. And it's flying this way. And we also have the wind. So a jet plane is flying with the wind, and it went 1,980 miles. So from the start of its journey to the finish was 1,980 miles. Now, when it flies back the way, this way, it's flying against the wind. So obviously going this way is going to be much quicker than coming back. And they were told that when it flew back the way, it could only travel 1,720 miles. So it managed to get from there to there, which is 720 miles, in the same time that it did this one. So we've pretty much got the story. The question is find the rate of the plane in calm air and find the rate of the wind. In other words, if the plane was flying and there was no wind blowing, what would its speed be? And what's the speed of the wind? Now that means I know what I'm trying to find. I'm going to make the speed of the wind be called x. And I'm going to be the speed of the plane if it was flying in still air to be y. So you can imagine this is x and this is y. So far, so good. So what we're going to now do, and I should tell you that somewhere up here, the journey took 4 hours. Okay. Right, let's do the journey when it was flying with the wind. The total speed when you're flying with the wind is x plus y. And if you did it for 4 hours, it would be 4x plus y. And in that distance, you covered 1,980 miles. So I've set up my first equation. I'm just going to tidy up a little bit. It's 4x plus 4y equals 9,800. Call that equation 1. Now, on the way back, your total speed is not the same. Well, the aircraft is flying at y, but the wind is pushing it back by x. So for the 4 hours that you're traveling, it's going to be y take away x, and that is 1,720 miles. So if we distribute this, we get 4y take away 4x is equal to 1,720, and I'm now going to call that equation 2. So the two equations that we've got are going to be 4x plus 4y equals 1980. I'll call that equation 1. And the second equation, I'm just going to rewrite it so the x's go first and the y's go second. And you get that. Now, once you've set up your system of equations, right, your two system of equations, you then have a decision to make. And this decision is simple. Do you use the addition method or do you use the substitution method? Well, I'm looking at these two equations and I'm seeing something really nice. The x's are the same amount, but one's plus and one's minus. If you ever see that, addition method is the way to go. So you'll add these together and they cancel out, and you add these together and you get 8y. You add these together, you get 0, carry 1, 7, carry 1, you get that. And so I can now divide both sides by 8, which is what my calculator is for. And if you take 3,700 and you divide it by 8, you get 462.5. That's what y is equal to. And so I'm halfway solved. I'm now going to put the y equals 462.5 into any equation I like. I like the top one. 4x plus 4y equals 1980. So 4x plus 4 lots of 462.5 is going to equal 1980. So 4x plus whatever the calculator tells me that is. And 4 times 462.5 ends up being 1850. And subtracting 1850 from both sides leaves me with 130. Dividing both sides by 4 leaves me with 32.5. So I now know what I've been asked. The speed of the wind is x. So the speed of the wind is 32.5 miles per hour. The speed of the plane when there's no wind blowing is y, and that was 462.5 miles per hour. And we are finished. Normally what you do at the end of this situation is you look at the numbers and you put a bit of common sense. Does a plane going at 460 miles seem reasonable and the wind being 32? Yes. If for some reason I switched places here and I thought the wind was blowing at 462 miles an hour and the plane, if there was no wind at all, would be blowing 32 miles an hour, those numbers wouldn't make sense. Also, if I got a negative number for both or either of them, that wouldn't make sense. So you can always use context as a kind of sort of a check. Do the numbers seem reasonable? If they do, that's a good sign. If they seem unreasonable based on reality, then you might want to check whenever you're working. As you can see, there's a lot of setup involved in these questions. They are not going to be easy, but that's what they are. Now, that was question, essentially the one I just did a moment ago, was question 1 or similar to it. And I'm looking at question 2 and question 3, and they're essentially the same type of story. So use the same method. And so is question 4. So let's keep going. Now here's question 5. And in this story, a plane is traveling with the wind, so it sounds like it's going to be very similar, but there is a difference. That's why I'm doing it. There's my aircraft. And here's the wind. Wind's blowing this way. Aircraft's going that way, so it's traveling with the wind. And a plane that's traveling with the wind, it flew 4,185 miles, and it did that in 6.75 hours. Okay, little separation. Now against the wind, so that's aircraft going this way now. Wind doesn't change, aircraft does. And against the wind, it managed to fly the same distance, but it took it 7.75 hours. And we're being asked to find what the wind is. So the speed of the wind, I'm going to call it X. And what the speed of the aircraft if there's no wind blowing, which we're going to call Y. So X is the speed of the wind. Y would be the speed of the plane in still air, right? So if no wind was blowing. So I'm going to take the information that I've got visually here. When you're flying with the wind, your total speed is X add Y. That's your total speed. And you flew that distance in that number of hours. So what that tells me is if you do 6.75 hours going at that speed, you will have covered 4,185 miles. If I distribute that, 6.75x plus 6.75y equals 4,185. There is our first equation. Now on the way back, your total speed, well, let's see what it would be. Y take away X again. And you're going to fly for that number of hours, and this is the distance you'd cover. So that tells me if that you travel 7.75 hours at that speed, you'll cover 4,185 miles. I will then call that 7.75y, take away 7.75x equals 4185. And there is my second equation. So I'm going to put those two equations next to each other, and we'll move on to the algebra part, which is how do you solve a system of equations like this one. And I'll switch the order because it looks nicer. Right, so we have an issue. We're going to have to solve them. First thing that strikes me is the numbers are ugly and they are decimals, but I still have to work with what I've got. And what I'm looking at is, do I go addition method or do I go substitution method? I don't think either method is going to be pretty. Sometimes, like the previous question, all the x's are the same. One was plus and one was minus. We're good to go. Here, nothing's the same. And I'm going to go, for no particular reason, I'm going to do the substitution method. So I'm going to take equation 1. As ugly as it is ugly. And I'm going to rearrange it to be y equals. So even when the terms that you're dealing with are big and ugly decimals, the process that I use is not going to change. I'm going to subtract 6.75x from both sides. I'm then going to divide everybody by 6.75. And that becomes negative 1x. And that becomes 4185 divided by 6.75. So can't do that in my head. So try that again. 4185 divided by 6.75 is 620. So actually, kind of amazingly, that's actually a nice equation. Well, what I do with the substitution method is that I put y equals negative x plus 620, and I put it into the other equation, right? So if I use this one to get y equals, always use the other one as the second part of the process. So I'm going to do negative 7.75x plus 7.75y equals 4185. And I'm going to do that guy plus 7.75 negative x plus 620 equals 4185. The alternate would have been to actually take this equation and make it y equals, and that would have worked as well, but that would have taken a lot longer. So I'm trying to do something a little bit quicker. So we have this fella. Oops, that's a minus. This fella. And if you multiply them together, you get plus 620 times 7.75, and I get 4805. Now you combine these, you get negative, I think that's negative 15.5. Let's check. Yeah. Yeah. Negative 15.5x plus that guy equals that guy. Going to take 4805 away from 4185. 4185. Subtract from both sides 4805, and you get negative 620. And then to finish, divide both sides by 15.5. So negative 620 divided by negative 15.5, and the answer is 40. And normally when you get to a nice answer like that, it's kind of pleasing, and it's also a very good sign, because I now know that x is 40, and I'm halfway solved. Then find out what y is equal to. And I'm going to put x equals 40 into any equation I like this one, so I'm using it. Negative x, add 620. So that's negative 40, add 620. And that gets you 580. So way at the beginning, we figured out that x is going to be the speed of the wind. And that was 40 miles per hour. And y was going to be the speed of the plane in still air. And that is going to be 580 miles per hour. And that looks good. And it's also correct. So that is a kind of slightly different, but enough to make a difference on how to solve an equation like that. So let's move on to stories and puzzles that don't involve aircraft flying or boats going up rivers. So our next question is number 6. And here a merchant mixes £10, I'll call it cinnamon for short, sin tea. And he mixes it with £2 spice tea. And to make that, based on its ingredients, they cost a total of $32. And now he has another different mixture, £12 is cinnamon tea, and he adds £14 spice tea. And to make that mixture, based on the price of its ingredients, that has a total cost of $79. And we're being asked, what is the cost of cinnamon tea per pound? So I'm going to call that X. And the cost of spice tea per pound, I'm going to call that Y. So when we're finished, I'm going to say that stuff costs $5 a pound and this stuff costs $12 a pound, right? Whatever it happens to be. But £10 of this tea and £2 of that tea, right? £10 of that tea at X dollars a pound, plus £2 of this stuff, so that's 2Y, comes to $32. There's your equation 1. This one, £12 of the X stuff, right, the cinnamon, plus £14 of the Y stuff is 79. And that is the key. I now have a system of equations, and you can solve that by the addition method and by the substitution method. You could probably even do it graphically if you wanted to. And if you solve it, which you will, you'll be able to find out what X is, and the answer goes here, and that's how much cinnamon tea costs a pound. And you'll find out what number Y is, and that will go here, and that's spice tea per pound. We're done. So I'm not finishing that, but giving you hopefully a good start to it. The next question looks a bit like question 7. During 1 month, a homeowner uses 200 units of electricity and 110 units of gas. I'll say so. 200 units of electricity and 110 units of gas. And his total bill for both of those added together is $82.70. Now, the next month, his electricity usage went up to 210 units, and his usage of gas, wow, went a lot higher, 250. And of course, his bill would change, and it's now increased to $109.70. And we are being asked to find the cost of a unit of electricity, and I'll call that X, and the cost of a unit of gas, and I'm going to call that Y. So 200 units of electricity at X units will cost you that much. 110 units of gas at Y units cost me that amount, and that's going to be $82.70, and there's my first equation. 210 units of electricity plus 250 units of gas gives me that. It's my second one. And we are over the hardest part. Now you just need to solve that system of equations. You could do it graphically, you could do it using substitution, you could do it using elimination. Try and find the math that is the easiest, right? Sometimes one way is a lot simpler than any of the others. And we're almost finished. Question 8 has a company that manufactures both mountain bikes and trail bikes. I honestly don't know the difference and what a mountain bike looks like. I'm just not sure what a trail bike is. And the cost of material for a mountain bike is $50, and the cost of material for a trail bike is $40. The cost of labor to manufacture a mountain bike is $70, and the cost of labor for manufacturing a trail bike is $60. During a week in which the company had budgeted $2,000 for materials and $2,900 for labor, how much of each bike could they produce? So I'm going to look at the two types of bike and say the amount, that's how many they produce, of, what's the first one, of mountain bikes. And we'll call that X. So maybe X is they make 10 mountain bikes or 2 million mountain, it don't matter. X is representing that one. And the amount of trail bikes, I'm going to call that Y. Now I'm going to return to the story, and it tells me that material first, it's $50 to build, material costs at least for the mountain bike, and it's 40 for the trail. So for every one of those X's, it's going to cost me 50X. And for every one of those Y's, it's going to cost me 40Y. And that is equal to the $2,000 that they budgeted for materials. So $50 to make that bike, materials, $40 to make that bike for materials. They've got $2,000 of material. That's my first equation. My second equation would be labor. And labor is $70 to make that bike. And it's a little bit cheaper, $70 to make that bike. And in this case, you have $2,900 to do that. So far, so good. Now we want to solve this equation, and I could certainly put it into Desmos and graph it, although I'd have to work really hard on the scales. And so I'm really not that keen on doing that. So what I'm going to do is I'm going to take equation 1 and I'm going to do a divide by 10. So that now becomes 5x plus 4y equals 200. And I'm going to take equation 2 and I'm going to divide it by 10. And that becomes 7x plus 6y equals 290. I think these numbers are much easier to deal with, agreed? Now you can solve them any way you wish, but you'll be able to solve the equation, and allegedly, this is interesting, that the answer ends up being 20 and 0. So in fact, the company only would make 20 mountain bikes and don't make any trail bikes based on the restrictions that they've given up here. Interesting result. And our final question is coming up now. So question 9 says a chemist has 2 alloys. One is 10% gold, and the other, in my story at least, is 10% lead. And the second alloy is 20% gold and 50% lead. And we want to know how many of each one of these, right? So I'm going to call that X and Y. So we want to know how much of X and how much of Y to mix together so that you can make 62 grams of gold and 86 grams of lead. So we're looking at setting up a system of equations that essentially takes this alloy and mixes it in such a way that you get this as your output. So I'm going to see if I can set this up now. If I use X amount of this and Y amount of that, how much gold am I going to get? Well, I'm going to get 10% of whatever I make is gold. So that's 0.1 X. And whatever I use of that is going to be 0.2, that's 20% Y. And that's going to get me 62 grams of gold. So there's my first equation. Now, if I look at the lead side, I'm going to get 10% lead. And I'm going to get 50% lead using the other alloy, which is 0.5. And that is going to be 86. And there is your equations. Now, I don't like decimals, so I'm going to do a slight algebra trick. I'm going to multiply equation 1 by 10, and now it becomes X plus 2Y is 620. And I'm going to take equation 2 and multiply it by 10, and now it becomes X plus 5Y equals 860. And when I look at these two equations, I think I know where I'm going to go. I could do the addition method, and that's what I'm choosing. So I'm going to multiply this by -1. So I'm now going to have negative X, negative 2Y equals negative 620. And that's my new equation 1. And I'm going to leave the second one totally alone. And now I have a plus and a minus X. Addition method likes that. Add them, they cancel out. Add these, you get 3Y. Add these, you get, I believe, 240. Divide both sides by 3, you get 80. So I already know that I should be using 80 of this stuff. So use 80 grams of this stuff. And if I had time, I would show you the working, but can you trust me? When you solve for X, you get 460. And so that means I should use 460 grams of this stuff. And we are finished. And hopefully that is of some use to you. Have a nice weekend. Remember that your homework assignment 2 and your online test 2 is due midnight this Sunday. When's that? 17th of July. And whenever you click on the online test 2, you'll have exactly 2 hours to complete it. So don't hit it until you're ready. There are no extensions for tests. So remind you, if you don't do it, you lose it. So hopefully you can get some time this coming weekend and tomorrow to be prepared. So bye-bye for now.